sticky bit on. If you make the changing the sticky bit on, means that this one, then the ownership of the disk, it will not be managed by each owner. It will be managed by the owner of the disk directory. It's a root. It's a stick. Okay? So you cannot change. Only owner of the file will take care of that temporary file. It's a sticky bit. So it cannot be it cannot be managed by the others, even though it has a permission to the others, but it will be managed by the owner. So that is a sticky bit. Another thing is so what is the purpose of the sudo command? Anyone?
Super user. What is super user can include?
Switch user. So SU is the command. Switch user. You can change the user. You log on as the Lee. Then I'd like to change the logon ID to the LJE. Then you can use the SU. It's a switch user. And also sometimes I'd like to be an administrator. You need to log on to the administrator. What is the administrator user in the Linux? The root. It's a super user. It's not recommended to log on as the root user because you can do anything. It's sometimes happen. So log in super user, root user, then delete all the file. Including, yeah, that really happened. Accidentally you can delete. So it's not recommended to log on the administrator. Instead, if you want to do something as an administrator, super user, you can do the sudo command. Sudo command is the switch user to the super user. Then do something command. So even though you do not log on, but your command will be run by super user, root user. That is a sudo. So you can learn the sudo command as a JELE. The proper sudo ls. When you learn the sudo, you can do anything because it's a super user permission, which means this user needs the super user because JELE learn the command, right? Which means JELE should have the permission, for example, access the memory, access the process information, access the kernel, whatever. You need such a permission to do that. Then what happens?
Change back to the other when the command executes.
It can be used for, you need to grant, you need to give the permission to that user, even though you switch user. So to avoid, I don't want to give the permission to all the other user, but sudo sometimes is needed. At that time, if you see here, it's not IWX, it's the IWS. Instead of X, it's the S. Can you see the S? No? Why don't you come front? It's the S. Instead of X. This part is the S. This is called SetUID bit. That is a sticky bit, and this is the SetUID bit. SetUID bit means, so when you execute this file, my ownership is temporarily, momentarily changing to this user, super user. Okay? Which means I don't have to give the permission to this user. Instead, temporarily, the ownership of this command is changing to the super user. Okay? That is called, it's not always a super user, it's the ownership of this file. So you can run the command, the sudo command. While you are executing this command, you are like a super user. Okay? Temporarily change the ownership. That is the SetUID bit. So if you turn on the SetUID bit, so you don't have to give the permission to the older user. Instead, anyone who run that program, execute the program, temporarily get the permission, same permission. So it's a very secured way, but sometimes it can be used for hacking. So because while you are running, you can run, you have the execution permission, but while you are running, you will get super user permission. So hackers sometimes use such a sticky bit. So nowadays, sticky bit is not recommended to use, but it can be if you properly use, it can be used to manage the security issue. So that is a sticky bit, and that is a SetUID bit. You can do the group. So you can change the group, set group ID bit, set GID bit. So same thing for the group. When you change it with the code, SetUID bit usually used for 11. It's a 4644, something like that. 4 is additional, the code to represent the SetUID bit. Pretty much that's it. One more thing. When you create a file, did you specify this kind of permission, like the 755 or this thing? No, you didn't. It's a default. As a default, what is a default permission?
Reader.
So, read only? Let me check mine. So what is the simplest way to create a file? Touch. So, what is the permission? RWRR means 644. So 644 always the default permission, which means if you wanna create the executor file, sometimes you need to check what is the default. So you compile GCC, then you have the a.out file, but it's not running. You do not have the permission. Even though you create, you need to check what is the default, the permission. If not, you can give the change mode 744. Then you will get the execution permission. Then who decided this default permission? Root user. So there is a command umask. So umask means you can see the 0 to 2. It's a masking. Okay? Masking the 2 2. So sum of this one is the 666. As a default, the execution is not given because the execution is very important. So 0 to 2, umask is 0 to 2. The first letter you can ignore, that is for the special, the bit. So 0 to 2 means it's a masking. Masking means if you add up the 644, then it will be 666. So 644 will be the default permission. So you can change if you want the default permission using the umask, the command. Okay. Okay, that is. What about the Windows? Windows is basically same idea, but it's more like the descriptive, the explanation and interface. You can see the group of the user. The username or the group name is the same as the group, and also the permission is more the specific, but full control, modify, read and execute, read, write, the special permission. It's basically same as the read, write, execution, their combination. Okay, but it's slightly different, but basically the same idea. Okay. Yes.
Can you explain again about the 644?
644?
No.
This one?
No. This
4. If you can actually add the sticky bit. If you want to add so one of the example of the first sticky bit is the what if. So if you start you probably will take, or you are taking the database course. In the database course, we are using the MySQL database software, or sometimes I use the Oracle database. For example, Oracle. It can be MySQL. It doesn't matter. What if when you connect the database, what happened in the database side? When you connect the database, can you imagine what happened? What does that mean, connection? Port should be open. Port is like the door. Door should be open to get inside. What happened really? Connection will be established using TCP/IP. So this is the computer, and this is the operating system. There are processes, server-side process like the Oracle. This is a process. Actually, this is a program. Then, when you connect, like the SQL, connect this one using the TCP/IP. So port number and the host name. Then connect. It's like a client server. Same thing, web server, same thing, FTP, any TCP/IP protocol, any application that are using the TCP/IP is the same thing. When you connect, if you make there are details of inside the handshaking or whatever you can learn from the networking class. But if you successfully connect the server side, what happened? There is a process. Process means memory. Okay? Process, Oracle process will be created. So, using what? Fork and EXE. That will be, child process will be created. It's copied. What about the web server? You have an Apache daemon. If you connect using the web browser TCP/IP, okay, HTTP, okay, then Apache daemon will be copied, cloned. However, nowadays we are using multi-thread. We have number of the daemon, and they will take care. But if you do not use the multi-thread, process will be copied. So, for example, Oracle has all the permission to access the file, memory, and so on. So, if you wanna connect the Oracle server, this one to create the process, you should have all the permission. But your super user, root user will not give the permission. At that time, you can set this file, executable file as a sticky bit. If you turn on the sticky bit, even though you do not have the permission of the super user, but you are pretending while you are using your database. You can access the file, you can access the memory information, you can access the process. Then, how can we turn on that? We can change this value plus X using code, binary code 4755. One more, the number 47. So 4 indicate the sticky bit. Or if you are using this S plus the other. S means the sticky bit. So S plus O. You can add the sticky bit to the others. Okay? But this one I don't explain details. You can check from the manual. But if you wanna add the sticky bit, change mode 4755. So this is another number to add to turn on the sticky bit. I don't think it's easy to understand from the this one is explanation. Best way, you can create a file and change it, the permission, and try to run or do something. It's I think that's not the beginner level, so more like the intermediate level, the Unix command. Okay, next. Finally, so we are going to implement the file system based on the idea so far, like the file system I/O interface, the file system interface. So then we are going to implement the file system. What is the file system? Data structure for what? Managing the files. Okay, where your information and data are stored. So we'd like to manage a number of files. There are two things we can consider to in the file system. One is file structure, and in case we have bunch of files, we can consider directory structure. So these two are the main things. So in your file system, you should have the what is a file, what is the definition of file, which means what is the data structure of the file. Then how to manage such a file using FCB, then the directory structure can manage such a file control block. We will see what is the details of the FCB information. Then, as we discussed a lot, the file system itself is the data structure, which means we can implement. So actually the file system itself is the software. Software means you are able to code. So in your project too, you are going to implement code such a file system. So because for a while, for a long time, even the first time when you use the computer system, operating system, file system has been used a lot for a while, right? So it looks like the really part of the operating system. Yeah, it's true, it's a part of the operating system, but even at that time, the file system was coded, implemented separately, then added to the operating system, like the Windows browser, not Windows browser, web browser, like the Explorer or Firefox. What are they? They are application program to use the internet service, HTTP service. In case of the HTTP daemon, web server, and your client is what? Your internet browser. That's because both of them are understanding HTTP protocol, HTML the tag. So they can display, they can request and receive display nicely. So that is the So that's how it works. Then sometimes people believe the internet browser is like the operating system, and that was a suit in the EU, Europe. So Microsoft include the Internet Explorer as a default, but there are other software companies who develop the internet browser, like the Firefox or the Opera and others. It's not fair, right? Because as a default is included. So because of that, that is one of the indicator. So internet browser is not actually the operating system, is the application. File system is the same thing. So you can have consider file system as a software, then you are able to implement, you are able to code if you understand such a data structure. So in this the chapter, we will see a little bit more details, the functionality. Based on the chapter 10 and chapter 11 discussion, we will see what kind of functionality and what kind of operation should be implemented in the file system. Specifically, your project 2. The project 2, most of the things that we are going to discuss will be implemented in your portable file system. So file system is deal with. However, even though file system is reside on the secondary storage, that's partially true. The first chapter 10 we talk about sometimes the solid state disk. They have the logical block addressing, LBA or LBN number. So we have the logical block number 0, 1, 2, 3, and the SSD has the same thing 0, 1, 2, 3, 4, 5, 6. Okay. Then there exists the very basic file system. If we want to use directly this one, this is the low device. Not low PC, it's a low device. However, it's not easy to understand the sector number, cylinder number, track number, and hard disk write number or the solid disk number. Then access this data offset. It's not easy. So instead, sometimes this basic file system is a part of the device program. So anyone who purchased a 10 megabyte hard disk drive or 100 megabyte? Anyone? So I purchased a 100 megabyte size hard disk drive. Then it took a long time to install because as we have seen in the computer architecture at the beginning of the semester, any I/O device should be connected to the what? Directly the computer system through the before bus. Bus is kind of highway controller. So there is a controller. What is a controller? Controller is like the very small computer, okay? Embedded system. It has even the instruction itself inside. Main job of such a controller is what? Control I/O device, each device. So this controller has the very basic software or instruction that can understand the block number to the cylinder number, physical location. Okay. Then on top of that, there is, for example, general purpose file system like the NTFS. This NTFS includes most of the general purpose, the functionality that you need, like the file, definition of the file, or directory, or the link, soft link, hard link, or shortcut, or anything that we have this, or directory structure will be included. Then I need a special purpose file system, like the TMP, or the process file system, or even sometimes a distributed file system. You can develop your own file system on top of this. Okay? So these are the files. So file system is not only just the NTF that you are using, it's mostly used general purpose. But in addition to that, there is a basic file system also. There is a specialized file system or user-created file system. So we are going to discuss about the most of the section of the file system. Then the file system manages the file through the what? Using file control block. As if the process control block in the process management. So in the process management operating system, use many information about each process, right? Do they access each and every process, the memory location, and check this one? No. Instead, operating system collect the useful information, needed information, then create the data structure that is called process control block. So there is a process table in the memory. So through using the process table, for example, if you create a child process, then process ID is allocated to the created, and then such information will be stored at the process table. Then operating system access only that process table. Then through the PCB, process control block, the operating system can understand everything. Sometimes decide the next process or scheduler and so on. Similarly, the operating file system manages the file control block. Okay, so before we talk about the file control block, the most of the file system, computer system use such a layered file system that I explained. It's a little bit more detailed. This is hardware. The bottom one is the hardware. Top one is the application program. Mostly we are using the application program, but operating system is in charge of in the middle. And how? This is a controller, and the basic file system is the program also. So implemented, mostly embedded program or the device program. So when I purchased the hard disk drive 20, 30 years ago, so I need to install that program. Usually the device program is the shipped together. It's not shipped. I usually purchase in the shop. So, but I need to install to the operating system Windows. Sometimes it works, sometimes not. If not working, I need to contact the customer service, then get the new driver program. It's a all variety. But nowadays you don't have to, right? Have you ever installed the driver program? You just plug in, play. Means one thing is standardized. It's already standard like the USB. It's already standardized, so you don't have to install. And also some specific the hardware. Each and most of the operating system company like the Windows, they release the roadmap next 10 years. When is the next version, then give such a roadmap to the company who developed such a hardware or the I/O device or the company. Then they follow that. If that is a genuine and approved by the Windows, for example, it's shipped with the operating system. Nowadays, they do not include, so it's all connected. So when the device is connected, search the database and get the device from. That is the I/O controller and the basic file system. And the logical file system is the general purpose file system that you are using. And on top of that, we can have the variety of the file system. Sometimes we can skip the logical file system, general purpose file system. You can use directly our special purpose file system. And also sometimes, so we can have another level of the general file system. It's called the universal file system, because since we have the different heterogeneous file system, so do I need to understand each and every the command or the code for each file system? No, you don't have to. Instead, they are standardized. So that is a universal file system. It's a virtual file system. Okay. So NTFS is usually act as the universal, the virtual file system. Through the NTFS or the general purpose file system, you can access the others. Okay, so these are the details of each layer. So I already explained, so you can easily understand that. Okay, so there are many file systems. Okay. What about the CD-ROM? What are such the optical device? They need also file system. Okay. In case of that is the read-only, you can put the mount as a read-only, and FAT, FAT32. I don't think that you are using the FAT file system. It was used a lot before, but nowadays mostly NTFS in Windows. In the Unix and the Linux, the system is the ext2 extension file system 3 and the higher number that we are using. Nowadays, we have the new file system, the no longer Google file system is right now Hadoop, the distributed file system to deal with big data. So we have the more and more the file system. The reason why recently I offer the project to portable file system, some of the students complain, do I have to implement code the file system? No, you don't have to. You may not. Most of the students. However, so nowadays to deal with the main idea of the big data is the distributed file system. So that one of the most popular example of the distributed file system is the HDFS. Hadoop Distributed File System from the Apache Foundation. And they are from the Google file system. Google developed that distributed file system. Idea is simple. In case we have the huge amount of big data, distribute. Okay? Then how to deal with such the distributed file? That is a key part of the HDFS. Then very basic idea of the architecture of the HDFS is exactly same as your portable file system. Okay, so if you understand such a portable file system that you are implementing, however, the main part of the core part of the second project, portable file system, is not coding skill. Okay, most of my project doesn't require the high level coding skill. Instead, whether you are able to convert data structure to the programming. To do that, you need to design your data structure. Like for example, I'm going to explain the FCB, file control block here. This FCB, some of the students just memorize the contents of this one for final exam. So that's also the good, but more important thing is whether you can implement this one using the program. In your program, you need to, if we learn this one, you should think about how I can implement this. Any idea? For example, you can define struct if we are using C or C++. If we are using the object-oriented programming, so it can be one class. Okay? In the class, where the drive keep this information. It's a memory. If you instantiate, if you create the object using your class, it's only in the memory. What about the hard disk drive or the persistent disk? You need to think about such a thing. Okay, so these are the well-known files more and more. So sometimes the application program use a very specific file system. Okay, so we are not going to implement all the functionality of data structure of the file system that we are going to discuss here, but for your better understanding, we will discuss and also. Okay. And the file system also includes the boot control block. Boot control block means it has the master boot record that has the location of your operating system kernel. So if you can remind what we discussed at the very beginning of this semester, so when you turn on your computer, what happens? Your BIOS program is running. It's also operating system. Main purpose of the BIOS is what? Checking the hardware. Check all your hardware. Whether CPU, how many CPU, whether there's new hardware or after checking all the hardware, it's electronic. Okay, signal, send the signal and check it. Then if everything is ready, next step is there is information where is the boot record. Okay, which device will be, which I/O will be, which storage will be used for starting your operating system. So there's the order. In your BIOS program, you can specify the C, D, CD-ROM. That's the order of to find the boot record. Okay, if you specify the C drive, for example, C drive has the boot record. And if you have the D and the D drive, sometimes you can use the multiple operating system, Linux plus Windows. What happens?
You would actually pick which one you want to start.
Using the loader. So there is a loader program to load your operating system, like the Lilo is mostly used in the Linux system, and also I think the group GRUB is another popular one, and even Windows use the loader. It's called the anti-loader. From time to time, if you accidentally shut down your system, it shows the safe Windows end or the without, something like that. You can choose that.